Hi, welcome back. In this lecture, I want to spend a few words about an interesting tool called PySpy that we are going to use to introspect existing processes running application. The internal learning outcome of this lecture is to use the PySpy tool to profile running processes and understand what are the computational characteristics. Let's say a few words about PySpy with on the minus here to not be confused with the PySpy altogether. So pi minus pi is a sampling profiler. So is a profiler that is sample randomly our application and check the performance. So rather than requiring any code change, for instance, adding decorator to the code, it introspects any already running Python process or any process that we want to start. And it reports in console, for instance, in our command line, it reports in a top-like display. So probably you know the top command in Linux that allow us to check all the running processes and how much resource uses is going on. So the output is similar to this Linux command called top. So being a sampling profiler, instead of checking for line by line in our code, it has very little to no runtime impact on our code. So we can get it run without having worry that is delaying our application run. It's written in Rust, originally in Rust. One important point to know to use it is that it requires an elevated privilege to introspect another processes. So we can introspect any process, however we need privilege in order to do that. To do that, from the command line on our laptop, on our computer, we need to pre-append sudo before actually running Python and our code. And this sudo will allow us to acquire super user privilege. We will need to put our password when we do sudo python and call the PySpy. So that also means that we can do on our own computer, laptop or workstation, where we are an administrator, but not in the lab computers, for instance, like KTH. That's not really possible. This tool is particularly important and very useful in production environments with long-running processes and complicated installation requirement. So we keep monitoring, what's going on, different processes and resource usage. So there are two main ways to use the PySpy. So we call PySpy top or record. If we do py minus py stop and then minus Python and the name of the program that we want to run, for instance, Julia set a code, it's going to create, as I told you before, a top-like graphics with updates. So here on the right side of the slide, you see this top-like window that the PySpy allow us to get. So that's a possibility, and this is as you can see, is very nice way to check what is the percentage of the time that is taken by the different parts of the Python code. So that's one way to use PySpy top. The second one is actually to produce a plot. To do that, we use a PySpy's record instead of top, and then we provide the name of the file we want to have our plot. So in this case, we do profile.svg, and then again minus Python myprogram.py, where myprogram.py is the name of the code that we want to introspect. When we do that, the PySpy creates a plot with the profile information. Like we saw, for instance, for SnakeFix, the width of the display represents the entire program runtime, and each layer moving down to the image represent the different function, right? So we go down this image and we see different functions that have been used on our code. So to summarize the usage of PySpy and what it's good at, PySpy is a sampling profiler that provides profile information using a top-like window or a plot. To run, it requires a super user privilege. Finally, is a useful tool, especially for monitoring long-run processes installation. So we can have a window and we keep checking what was going on our Python code. Talk to you soon.